So in the last discussion, we talked about how to take your models which are logged, which are hidden inside a run, which are stored within the artifact store, and take those model and put it inside a separate store, which is essentially referring to the same thing but now with some enhanced metadata. Registered models are just the same model but with some additional metadata tags which helps in organizational and operational aspects. In this video, we will quickly look at how to take those registered model or any model for that matter, even those which are logged within the run, and deploy it using a HTTP based endpoint. You might be wondering or maybe worrying that I don't know about Flask or maybe a fast API. How can I do that? The answer is you don't need to know any of those things. How can you then run a HTTP based server? Just open a new terminal, activate your virtual environment and run this. MLflow provides a utility called model serve. Now after this serve, you need to provide some arguments. The first one is M for model. In the model, you want to specify the URI that we discussed in our last discussion. The URI follows this format: models : // Let's go to the registry and let's grab the model's name. So best production model, let's grab this and let's paste it here. And we also need to specify the version. So let's use the second version. After that, we need to use the port. Port, we can use anything. Let's use some random port. I don't know why. I don't know how I came up with this number, but yeah. But sometimes what happens is I use some random ports and there is already an existing service using that same exact port. And in that situation, MLflow will throw an error. Finally, there is this argument which you need to specify if you are not willing to serve this model using container based setup. So I'm specifying no conda. If I run this, it will it has basically started this process, and it has started a server on this URL. Now this URL by default exposes several endpoints such as invocation, health, etc. Let's try out this. Let's curl into it. Let me grab this URL first. Control C and let me paste it here. If I hit enter, it says not found. But let's call it health. In health, it does not return anything, but it is not also giving us any error. There is one in particular endpoint, that is invocation. Invocations. Yes. You see, method not allowed. So it's saying this method is not allowed. Why? Let's see. 1 second. Let me expand this. Okay, it's saying 405. In the health, it said 200. Okay, but in this, it is saying not found. Why it is not able to find? Because invocation is the one that I must have misspelled it. Invocations. Why? Okay, let's pass the argument. I'm not getting why it is not accepting our request. Content type application JSON, and we also need to provide data. In the data, I'll wrap this data in here. Let's pass inputs. Inputs would be a list of all the rows that you want to get the prediction for. Yes, you see? Okay, so method was not allowed. Somehow when we don't pass data, it simply does not return. But let's see. If I remove this 4, it will give this error that X has 3 features, but logistic regression expecting 4 features as input. So our model was trained. Now, where did we set up this? Let's look at this. When we created this data using make regression, if I recall correctly. Oh, no, load iris. So this is what we used, and inside here we have 4 features. That's why it is requesting for 4 features. Okay, so that's it. That's how you basically set up a HTTP based model server using your registered or logged models. Now this is very simple actually, right? But this kind of setup is only ideal for real time inferencing, or in ML system terminology it is known as online inferencing, where you deploy this REST based API into a Lambda function or maybe Azure functions, and then you start accepting some requests, and then you serve those requests on the go. Okay, but for the batch based requirements, you might have to create a script and call load the model, and that batch setup, how we can do, we can load the model using sklearns dot load method. Let's try it out. Okay, so let me now create a new script maybe, and inside it I'll just import MLflow, and I'll say MLflow dot load dot sklearn dot load model. Inside here I need to specify model URI. So let's use this same model URI that we just deployed. One second. Okay, so this is the model URI that we basically chose. So let's grab this, and I'll say model URI, and inside here I can pass this, and what I will get in return is a MLflow model, which I can use for batch inferencing. Okay, let's run this script. Just 6. Okay, so you see it is printing logistic regression, and that's what our model is. Now we can use this model just like we would use a normal sklearn model. Okay, so this is how we load a already registered or logged model for our batch inferencing workloads. And for real-time inferencing, for online inferencing, we just spin up this nice looking server. I hope it is making sense.